Hello everyone. This question on board is a question involving resistivity of a wire. You know, a conducting wire has factors that affect it, which is the length of the wire, the temperature at that particular point of the experiment, and the area, cross-sectional area of the wire, and the nature of the material. Therefore, I will now treat so many questions involving the resistivity and the resistance of a wire, and also the conductivity of a wire. So please pay attention as I solve some of the questions, which this one will be the first, okay? The question says, find the resistance of a wire of length 2 meter, diameter of the wire is 0.2 millimeter, and the resistivity of that wire is 44 times 10 raised to the power minus 8 ohm meter. Okay, now what is the formula for it? Now the formula we are going to use is the resistance of a conducting wire is equals to the resistivity of the wire times the length of the wire all over cross-sectional area of the wire. Okay, now from the question now, the length of the wire is given to be 2 meter, then the resistivity of the wire is given to be 44 times 10 raised to the power minus 8. Then cross-sectional area is not given, but we will get the cross-sectional area through the help of diameter of the wire that is being given. Okay, now how to get the area of wire is area of wire is equals to pi r square. Okay, now we can get our r by dividing the diameter by 2. Okay, now which means from this now, you know, in order to get r, we divide the diameter by 2. Okay, now which means if we can divide diameter by 2 to get r, therefore we can now do it this way. Pi is equals to, let's use d to represent the diameter, d all over 2, which will give us this. We now replace this r. I'm saying if you want to get it directly with the diameter being given, you still use the formula. Knowing that 2 divided by diameter will give us r, we can now replace this r here and put diameter divided by 2 raised to power 2, because r is being raised to power by 2, which will now give us pi. This diameter raised to power 2 is diameter raised to power 2. Then 2 raised to power 2 is 2 times 2, which is 4. So we can now use this formula directly to get the area of a wire. Okay, so let's use this thing since this is being given to us. You know that our length is in meter, therefore we have to convert this one to be in meter, which we will now do 0.2 millimeter divided by 1000. We now converted it to meter, which will now give us our pi is constant, which is 22 all over 7 times d square. And when we convert it to meter, it will now be 0.0002 raised to power 2 now. Okay, because raised to power 2 all over 4. And continuing our calculation, we now multiply. We now have 22 over 7 times 0.0002 raised to power 2 is what? Is 4 times 10 raised to power minus 8. Okay, all over 4, which is equals to area equals to this divided by 22 divided by 7 is 3.142 approximately. Okay, times 4 times 10 raised to power minus 8 all over this 4, right? Which will now give us, when we multiply this up 1, it will be 1.26 approximately times 10 raised to power minus 7 all over 4. And when we divide it, And when we divide it, we now have 3.142 times 10 raised to the power minus 8. That is the area we are going to use to solve for the resistance of a wire. Okay. Now calculating for the resistance, we now have resistivity is 44 times 10 raised to the power minus 8 times length, which is 2, all over our area, which is 3.142 times 10 raised to the power minus 8. When we multiply the up one, we have 8.8 times 10 raised to the power minus 7 all over 3.142 times 10 raised to the power minus 8. When we divide it, we now have 28 ohms approximately. This is how to calculate this. This is how to calculate the resistance of a conducting wire, right? Thank you so much for watching. Please make sure you subscribe and follow me, comment and share. Thank you and God bless.